Good morning.
Good morning. Nice to see you.
Lovely to meet you, Stephen. Impleo was conceived by listening to our surgeons and establishing that there was a need in the marketplace for a fully formed, form-stable, cohesive, soft implant. Hey gentlemen, this is our incoming goods material. We'll receive our materials from our certified supplier in the US. All materials are long-term implantable grade silicone materials. So before we go into the clean room, we have to get gowned up appropriately to ensure that we minimise any particulate release into the clean room environment. It's a fully pressurised clean room. The air changes approximately 30 times an hour. So welcome to the clean room, gentlemen. First place we're going to start is where the materials are pumped into the clean room, and then we'll go to shell manufacturing, and then we'll just walk the process from there.
And the Impleo mix is slightly different from other implants, isn't it?
Yeah, it's a specific mix ratio to a particular recipe to ensure that we can produce an Impleo product in terms of cohesivity and softness and form stability. And now we're going to dip the moulds or the mandrels into the dispersion to start to manufacture the shell. A number of processing parameters combine to produce the perfect shell. So we have the devolatilization conditions within the dipping cabinet, the number of layers that we apply to the shell, the viscosity of the dispersion itself, and obviously also we have the technique which we use so that everyone does the same process, for instance bubbles and marks. So that's the first layer that's been applied. In between the build-up of layers, there is a barrier layer, the SiloGuard barrier layer, to inhibit any gel migration through the shell. We have a 360-degree layer, so we have the barrier layer in the patch as well, so it's all the way around the product. Also the cohesivity of the product is important, so the cohesivity will also reduce your gel bleed. We've now dipped the shell, so now we have to cure the shell. So all the shells go into an oven on the mandrels as they were dipped. We've got the works order here, which is full traceability of the materials that are used within the process.
So you can see who did it, yes, where the dips were, the timing, airflow, and these initialized.
Yeah. And all the detail of the materials is all captured at the top. So the first thing we do, we'll dip the mandrels in the same material that is used to build up the shell. The shells are cured, remember. We dip the mandrels to create that tack layer. Leave it for a set period of time. If we leave it for too long, the texture will be too light. If we don't leave it long enough, the texture will be too heavy and it will start to get a spongy type effect. The depth of the texture and the width of the texture. So it's critical here that our timings are correct. So we've got a timer here, a timer on the other side. Once it's reached its length of time, it would then be transferred into the spray cabinet. The salt is then controlled by grain size, pressure of the guns, so we've got options to change the texture and depth and width from that point of view, and a number of different processing parameters. So he's going to spray the tops of the mandrels just now.
Yeah.
Having textured the shell and applied the texture layer, we then cure the textured layer again. They then get transferred into a salt water bath where we're going to dissolve the salt 30 minutes in here. Dissolves the salt. You can see that's wet.
So it is sort of mid-textured, isn't it?
Yeah, it is. It is. Yeah, you can see it. You can see it nicely. No.
So the first part of the process is create the information on the ID disc, on the identity disc, and that's what we're doing here. So we'll laser etch the details onto the patch where we've got the product code, we've got the lot number, and we've got the NAGOR name.
I always assumed that the weakest point of an implant was around the disc. Is that not correct?
The shell and the joints are tested to a similar specification.
this typical malleability, which is so nice with these implants actually.
Okay, gentlemen, we've done the clean room part now. This is the quality control part. In the clean room, there was a number of non-destructive tests that you saw. In here, we'll do our destructive testing. I'll pass you over to Richard, our quality manager.
What takes place here is we do all types of testing at all stages of the process. We are testing the elongation. How far can you stretch it? What sort of pressure can you put onto this before it breaks? Now we've got a limit of, we look at for 450% elongation.
Yeah.
As I say, it's...
Should I be worried?
No.
Okay. You're a big guy. You're a big guy, aren't you? Yeah. So with other implants, that you would have had a sticky, horrible mess by now, wouldn't you? I think that's 3. Yeah. Is that 3 twists? And how does it look when we go back?
Yeah. Look at that.
And then when it goes back, would you know it had been twisted? Not really. Yeah.
This is just to demonstrate the cohesivity of it. You can see I cut a flap. So when I do that, you can see how it adheres.
It sticks to that.
Yeah.
To the product.
I mean, it's soft. I mean, it feels soft, doesn't it, Michael? And it's very malleable, but cohesive, you know.
Yes. And what I can do is I can cut a flap in this one.
So if I give it a, yeah, so it is very cohesive, isn't it? And the idea is to get it cohesive,
yes,
but flexible, yes, and soft and resistant to fractures.
Correct.
I was very much impressed seeing how these implants are manufactured and how many actual handwork and manpower is behind the final product. I used this product for a long time. You never think it's actually handmade. You know, today there are many talk about safety. Safety for the patient finally, for the end user, for the surgeon using these implants. After this tour now, I see that there is a direct link between what I saw, how this manufacturing process is going on, how many testing there is.
Just coming out of the shell inspection area, I was really impressed with the tests they were doing, particularly the inflation test for any little even micro holes in the shells, and also how exact they were with testing the thickness. It does make me more confident as a surgeon to treat my patients with Nagor Impleo implants. I can see how dedicated and how exact the manufacturing process is. So a physically perfect implant with a very small, tiny visual issue will be rejected despite being perfect physically. And that makes me much more confident that I can give the best results for my patients.
You know what I like so much about Impleo implants, that it is possible still to have a nice, a soft, a pliable implant, which you can even twist around.
The gel is a very advanced gel, very malleable, so it lets me insert the implant through a much smaller incision than other implants.
Since we have anatomical implants, the round implants don't give you a natural breast shape, etc. Since we have Impleo, which is so soft and so pliable and still resistant in shape, you can achieve very, very natural result. Maybe having a little bit more upper pole fullness, I think it's a perfect implant.